Okay, good enough. We will start with types of graphs where we had left last time, then we'll continue from there. We had seen what is a null graph. This is a graph which contains only isolated node, is called a null graph. That is, the set of edges in a null graph is empty. So if you have only one node, so there will be no edge and the degree of that particular node will be 0. Then we had seen complete graph. A simple graph G is said to be complete if every vertex in G is connected with every other vertex. That means if there are 5 vertices and if you pick up any vertex, then it should be connected to the remaining 4 vertices. So degree of each vertex will be 4. Now in this case, if degree of each vertex is 4 and the total number of vertices are 5, then 5 into 4 will be 20. 20 divided by 2 will be 10. Hence there will be only 10 edges. Now if you remember the handshaking lemma, we know that the sum of the degrees of all the vertices is equal to twice of the number of edges. So first we computed the sum of the degrees of all the vertices. Each vertex had degree 4 and there were 5 vertices. So 5 into 4, 20. But 20 equal to twice of number of edges. So if I want to find out number of edges, then in that case, it will become 20 by 2, which will be 10. So if I had 5 vertices, then the total number of edges is 5 into 4 divided by 2. Same way, if I have n number of vertices, then the total number of vertices will be n into n minus 1 by 2. Why we are saying n into n minus 1 by 2? Because n is the number of vertices. It has to be connected to the remaining n minus 1 vertices. And since each vertex is counted twice, so we have to divide by 2. And this is what we had written down. In a complete graph, which is usually denoted as capital K underscore n or capital Kn, it should be noted that Kn is exactly n into n minus 1 by 2 edges. And these are the graphs. You can see K1 has only one vertex and no edge. K2 has two vertices and only one edge. K3 has three vertices and three edges. Now, if I have to find out how many number of edges are there in a complete graph, we said it is n into n minus 1 by 2. If I take n as 3, I'll get 3 into 2 by 2, which is 3. Similarly, for K4, there'll be 6 edges. 4 into 3 by 2, which will be 6. And then K5 and K6. This is what we had seen in the last session. Then we proceeded further with a regular graph. A regular graph in which all the vertices are of equal degree is called a regular graph. That means in case if I have 5 vertices and every vertex its degree is 2, then we call it as 2 regular graph. If we have 5 vertices and if degree of every vertex is 3, we call it as 3 regular graph. If we have 5 vertices and every vertex is connected to 4 vertices, we will call it as 4 regular graph. And we have also seen that a complete graph K5 is connected to the remaining 4 vertices. So K5 is called as 4. So if the degree of each vertex is R, then the graph is called as a regular graph of degree R. Note that every null graph is regular of degree 0 and that the complete graph Kn is a regular graph of degree n minus 1. Why it is n minus 1? Because in the complete graph, every vertex is connected to the remaining n minus 1 vertices. So its degrees n minus 1. Also note that if G has n vertices and every vertex has degree r, then how many edges will be there? As per handshaking lemma, I will have sum of degrees of all the vertices equal to twice of the number of edges. What will be the sum? Every degree is r and there are n vertices. So n into r divided by 2 will be the number of edges. Then we proceeded further with cycles. Now, for a cycle, I will require the number of vertices to be greater than or equal to 3. Just a minute. Cn is called as a cycle and it should consist of n vertices where n is greater than equal to 3. So we have v1, v2, v3 till vn and edges v1, v2, that is v1 is connected to v2, v2 is connected to v3 and so on. And if you see here, we are simply saying a cycle. In a cycle, every vertex has degree 2 because it has been connected to its two neighbors. So you can see v1 is connected to v2, v2 is connected to v3, and lastly v3 is connected to v1. This is called as C3 because the number of vertices are 3. Similarly, if you check with 4 vertices, 1 is connected to 2, 2 is connected to 3, 3 to 4, 4 to 1 back. So degree of again each vertex is 2. Hence cycles are also called as two regular graphs. Similarly, we have C5 and C6. Do observe that even these vertices have degree 2. So for a cycle, you connect it to neighbors. Now you'll say, who are the neighbors of V1? The neighbors of V1 are V2 and the last vertex, Vn. And that is why we have written down here that you have to connect from V1 to Vn all the vertices through edges, and then lastly V1 is connected back to V1. Then we proceeded further with wheels. We said we are taking cycles one notch ahead. So if we take cycles one notch ahead, in that case, we take C3 and in the center, we add one more vertex. Now this vertex is connected to all the remaining vertices. So the wheel Wn is obtained when an additional vertex to the cycle Cn for n greater than equal to 3 and connect this new vertex to each of the n vertices in Cn by new edges. So that becomes W3. Similarly, for W4, W5 and W6, we had added one vertex in the center and then this vertex is being connected to all the remaining vertices. We had seen this wheels earlier. Then we proceeded with platonic graphs. We said there are 5 regular platonic solids. Now, these solids are tetrahedron, octahedron, cube, dodecahedron, and icosahedron. So in the tetrahedron, we have 4 faces. You can see this is one triangle, second triangle, third triangle, and the other side we have fourth triangle. So it has 4 faces. You can treat this as a prism. So if I have a prism, I have to put up this prism or show this prism on paper or on a plane. Plane is two-dimensional. So hence it is said platonic. You're putting up this in a plane. And in a plane, if I am putting up 4 vertices, these 4 vertices are same as the vertex of your solid, and the edges of your faces becomes the edges in this graph. Then we have seen octahedron having 8 faces, cube having How many faces will a cube have? How many faces does a cube have? You might have seen a dais. In the dais, six faces. So tetrahedron, four faces, cube, six faces, octahedron, eight faces. Then we have dodecahedron, 10 faces, and icosahedron, 12 faces. So you have 2, 4, 6, 10, sorry, 2, sorry, 4, 6, 8, 10, and 12. If you have two faces, that becomes a plane and it is not a solid. So it should always start with four faces. These are the only five regular platonic solids available: tetrahedron, octahedron, cube, dodecahedron, and icosahedron. We have finished till this in the last session. We are proceeding with the n cube. The n cube denoted by qn. It is the graph that has vertices representing 2 raised to n bit strings of length n. So two vertices are adjacent if and only if the bit strings that they represent differ in exactly one bit position. I will be requiring these strings in the Hamming code, which is used for your finding out the number of errors when the strings are being delivered. If we take string of length 1, I will have 2 raised to 1 bit strings, which are those 0 and 1. Now 0 and 1 is differing in exactly one position, so you are connecting them by an edge. If you take length of n as 2, the length n as 2, you will have 2 raised to 2 bits, that is 4 strings. 4 strings means you'll have 0, 0, 0, 1, 1, 0, and 1, 1. So 0, 0 is connected to 0, 1, and 1, 0 because that is they're differing only in one position, exactly one bit position. I cannot connect 0, 0 to 1, 1 because it is differing in 2 bit positions. So we are connecting 0, 0 to 0, 1, 0, 0 to 1, 0. Similarly, 1, 0 is connected to 1, 1, and 0, 1 is connected to 1, 1. And then if we take n as 3, we will have 2 raised to 3, that is 8 strings. So if I have 8 strings, this is how in a cube we are connecting. You can note 0, 0, 0 is connected to 0, 0, 1, 0, 1, 0, and 1, 0, 0. Similarly, the other vertices. Now we want to compare these graphs. If I have to compare these graphs, we'll have to check whether this graph is a part of this particular graph on the left hand side. Do you feel the graph on the right hand side is the part of the graph on the left hand side? Yes or no? Do you feel that the graph on right hand side is the part of graph on left hand side? Yes or no? Or still wondering? Only one person is saying yes. Others? Okay, even one more person got the thing. If you're not able to imagine, please check this vertex. Please check this vertex 1, 2, 3, and 4. These four vertices. So just notice that the graph on the right looks like it might be the part of the graph on the left hand side, especially if we draw it like this. You can see what we have done. We have drawn this graph, the graph on RHS, as this particular graph. And we see it is a part of the previous graph. Such kind of graphs are called as subgraphs because you're taking a part of it. As we have sets and subsets, we take some part of the set, we call it a subset. So I'm taking a part of the graph and then we are calling this particular as subgraph. So we are now defining what is a subgraph. Please pay attention to all these definitions because I'll be requiring this heavily in the future sessions. If G and H are two graphs with vertex sets VH and VG, so now I have two sets of vertices, one for the graph H and one for the graph G, and H sets EH and EG respectively, such that VH is a subset of VG. So set of vertices of H is a subset of vertices of VG. Please note, it is not a proper subset. It is subset. So it can be equal also. Similarly, your edge set should be a subset of H graph and G graph. Both edge set when you consider EH is a subset of EG. Then we'll call H is a subgraph of G or G is a supergraph of H. So in the previous case, when we had drawn this particular part, we had the number of vertices in the graph G. If I take this as graph G, this is 1, 2, 3, 4, 5, and 6. These are 6 vertices, but I have taken only 4. So V of H is a subset of V of G. So vertex set of graph H is a subset of vertex set of graph G. How about edges? Are these two connected? Yes. These two? Yes. These two? Yes. These two? Yes. These two diagonally? Yes. So we have taken all these edges and we have drawn in this particular graph. So my edge set is also a subset. Hence we'll be calling it as a subgraph. Now check with this. Is G and H having any relation like subgraph and supergraph? I have a graph having 6 vertices and check this is degree 2, degree 3, degree 2, and so on. And I am taking only the top vertices and from the bottom only this middle vertex. And then we have connected. We will be saying that H is a subgraph of G or G is a supergraph of H. Please take the screenshot for this. Then we are proceeding with spanning subgraph. What does this spanning subgraph says? It says your graph has to be a subgraph your graph has to be a subgraph. If your VH is equal to VG, then we call it as a spanning subgraph. Please note there is a difference now. Earlier we had said subset. Now we are bifurcating that or classifying that. If it is a proper subset, now you can see the proper subset V of H is a proper subset of VG. I don't care about edges now. edges will be a subset. If V of H is a subset of VG, we call it as a proper subgraph. But if V of H is equal to VG, then we say H is a spanning subgraph. First, we have found out about subgraph. Then, if all the vertices are in a vertex set of G, but there are one or two in G which are not in H, then we'll call it as a proper subgraph. But if it is equal, then we'll be calling it as a spanning subgraph. Now, we have a graph called G1. We want to know, is F1 a spanning subgraph of G1? Tell me whether it is a spanning graph of G1. Yes or no? So one thing we notice that our condition was only on the number of vertices. We had V1, V2, V3, V4, V5 in the original graph, and in this graph on the right hand side, F1, we have V1, V2, V3, V4, V5. And we also wanted whatever edges are there in F1 should also be in G1. So V1 is connected to V2 in F1. Is it connected in G1? Yes. V1 is connected to V3. Is it there in this graph? Yes. V2 to V4? Yes. V3 to V5? Yes. V4 to V5? Yes. What is not there is V2 to V3. That's okay because we said your edge set should be a subset. So if I remove this, I'm getting a subgraph. So we'll say F1 is a spanning subgraph of G. Please take screenshot for this. Now tell me whether this graph H1 is a spanning subgraph of G1. Is this H1 spanning subgraph of G1? Not getting any response. Indeed, it is a spanning subgraph because the number of vertices are same. Even though I have V1 as isolated vertex, its degree is 0. Here degree is 2. We have taken a subgraph from here and we have put up all the vertices over there. So it is a spanning subgraph. How about this? Is J1 a spanning subgraph of G1? No, because V1 is missing from there. It is a subgraph. Definitely, it is a subgraph of G1, but it is not a spanning subgraph of G1. Then what it is? It is a proper subgraph. So this is a proper subgraph of your G1. So this is not a spanning subgraph. Then we're proceeding further with, if I remove a vertex or an edge from a graph, then what is going to happen? This says the removal of a vertex Vi from a graph G result in that subgraph G minus Vi of G containing all the vertices in G except Vi. So if you have V1 to V5 vertices and you don't want V1 in that graph, so you're removing V1. If you're removing V1, what extra things you are going to remove? You're also going to remove all the edges which are incident with Vi. You're going to remove all the edges which are incident with Vi. That means G minus Vi will have all the vertices except Vi and all the edges except which are not incident with Vi. Now, for that, if you see, we have this particular graph. I want to remove this V1. If I remove this V1, then what will happen? I will have a graph, this particular graph, without V1. Without V1 means I'll have V2, V3, V4, and V5. All the edges which are incident with V1, I have to just remove this edges from V1. I will have a square. So that square will be G minus V1. So I will have V2, V3, V4, and V5. All of them are connected. That will become a graph with G minus V1. And we also call G minus Vi is the maximal subgraph of G not containing Vi. Why we are calling it as maximal subgraph? Because we are considering all the remaining vertices and all the remaining edges. There is no possibility of leaving any vertex or any edge. So if you are removing only one vertex, then all the edges starting from that vertex or ending at that vertex should be removed, and remaining full graph has to be taken. And hence we call it as maximal graph, or that is the maximum possible graph. Check in this. We have a graph G. I want to remove G. I want to remove V2 from this graph. Can you please quickly draw G minus V2? Take pen and paper and draw G minus V2 graph. Did you draw that graph? When you have drawn that graph, V2 is removed. That means V2 to V5, that edge should not be drawn. V2 to V1 should not be drawn. And V2 to V3 should not be drawn. Does your graph look like this? Okay. Draw this graph. You're removing now two vertices, V1 as well as V2. If you remove V1 as well as V2, please note from V1 there are edges V1, V5, V1, V2, V1, V3. Those will be removed. From V2 we have edges V2, V5, V2, V1 and V2, V3. So your graph might look something of this sort. Please check the difference between the first graph and the second graph. Things are clear till this long. If I remove a vertex from a graph, how my graph is going to look like? Do you have any doubt till this long? This was if we were removing a vertex vi. How about if I remove a edge ei? So now we are saying if I remove an edge, now we are taking edge as xj from G, yields a spanning subgraph G minus xj containing all edges of G except xj. G minus xj is a maximal subgraph of G not containing xj. When you are removing an edge and in the process you get an isolated vertex, then you have to remove that vertex also. We'll see an example over there. Assuming if I am removing V2, V5 from this particular graph, if I remove the edge V2, V5 from this particular graph, then V5 will become isolated. So I should remove that isolated vertex also. In this case, we are removing V2, V3 as the edge. So if I remove V2, V3 as the edge, then in that case, my graph looks like this. I have removed only this edge. Please note, after removing this edge, the degree of V2 becomes 2 and degree of V3 becomes 1. So I don't have any vertex whose degree has become 0. If the degree of vertex becomes 0, that vertex also has to be removed. Please draw the graph for this. Did you draw that graph? We're removing V2 to V3, V2 to V5, and V2 to V4. In the process, we got a subgraph, which is this. Some of the books will also say that when you're drawing such kind of things, just remove the edges and keep the vertices as it is. So if you're following that convention, then in that case, you will be keeping this V5 also. Depends on what convention you are following. As of now, we are saying if it's degree 0, then we'll remove that vertex. But some of the books will say, no, no, keep the vertices as they are. Only remove the edges. And if you're removing the edges, then it will become a spanning subgraph. Is it fine? So as per our definition, should I keep that vertex V5 or should I remove? Because my definition says it is a spanning subgraph of G minus Xj. Xj is nothing but your edge. So should I keep that V5 or should I remove that V5? According to this definition, what should I do? Is my question clear? Our definition says that if I remove an edge, I will get the spanning subgraph, which is G minus Xj. It is a spanning subgraph. It is not saying a subgraph, spanning subgraph. If it is a spanning subgraph, should I keep V5 in this graph or should I remove V5 from this graph? Because now V5 has become an isolated vertex. Please recall what is the definition of spanning subgraph. Spanning subgraph says all the vertices should be there. So should I remove V5 or should I keep V5? If I'm talking about spanning subgraph, then I should be keeping that V5 in this. And my definition also says it is a spanning subgraph, so I should not be removing V5. Had I said that it is becoming a subgraph, then I have a choice whether that vertex whose degree has become 0 should be removed. So in this case, I cannot remove V5 because my definition says it is spanning subgraph. So you will have to draw an isolated vertex V5. Is the point clear what we have done? So if you're removing a edge, then do not remove the vertices whose degree is 0 if you want a spanning subgraph. But if in the definition it is not spanning, then you can remove that. So in our case, we will not be removing because we have got it as spanning subgraph. All the vertices should be there. Then we are proceeding with induced subgraph. Please note all along what we have done. We have done spanning subgraph. What is an induced subgraph? Induced subgraph says your vertex set should be a subset of vertex set of H should be a subset of vertex set of G. Then subgraph H of G, whose edge set comprises exactly the edges of EG, which joins the vertices of VH, is termed as induced subgraph of G. Now, what do we mean by this? Many times in the graph theory, when you read the definition, it is not very clear until you see an example. Now, in this case, we have 5 vertices, and these vertices are being joined in some way in graph G. In H, I am taking only 4 vertices. Which are those? V2, V3, V4, and V5. So I should first draw V2, V3, V4, and V5. And then check. V2 is connected to how many vertices? V2 is connected to V1, V3, and V4. But V1 is not there in my H. So I'll be connecting V2 to V3 and V2 to V4. So V2 to V3 and V2 to V4. V3 is connected to how many edges? V2 and V4. So we have joined V2. We don't have this particular vertex, this particular edge, V3, V4. Similarly, V4 to V5. This is called as induced subgraph. Now, in this case, will I call it as induced subgraph? I may not call it as induced subgraph. Reason for that is what we had said in the definition. Subgraph H of G, whose edge set comprises exactly the edges of EG, which joins the vertices of VH. So if I have to induce something from G to H, then leaving V1, all the other vertices should have same form. So V2 should be connected to V3 and V4. V3 should be connected to V2 and V4. And V4 should be connected to V2, V3 and V5. But in this case, I see that V3, V4 is not connected. So if V3, V4 is not connected, I will not call it as induced subgraph. Is this point clear about induced subgraph? What are we doing in the induced subgraph? If there is any vertex in G which is not in H, then you're removing all those edges which are incident on that particular vertex. So it is as good as from graph G, you have removed the vertex V1 and then you are getting the subgraph. Check with this. Is H an induced subgraph of G? After removing vertex V1 from G, will you get this particular graph? Is it an induced subgraph? It has to be an induced subgraph because if I remove just V1, only this particular vertex and edge will be removed and remaining vertex which I have got is the induced subgraph. Again check, it is maximal subgraph after removing the vertex V1. So this is what we had seen for subgraph. In the subgraph we said the vertex set should be a subset, edge set should be a subset. So we have got VH is a subset of VG and EH is a subset of EG. Then we proceeded with spanning subgraph. A graph in which all vertices in G are also in H. A spanning subgraph does not need to use all the edges in G. So spanning subgraph was the vertex set should be equal. We don't care about the edge set. We don't care in the sense that still it should be a subset, but you can remove some edges from G. You cannot add new edges in G. Then we proceeded with induced subgraph. A graph which has all the edges in G that are between the vertices in H are also in H. So what was the induced subgraph? From a graph, we have removed one vertex. When we remove one vertex, all its edges are removed. The resultant graph which we are going to get is your induced subgraph. Is this fine regarding subgraph, spanning graph, and induced graph? Is the difference clear? Okay. Then we're proceeding with a definition of a walk. In a graph G equal to VE, a walk is a finite alternating sequences of vertices and edges. So what do I mean by that? We usually try to name the vertices as V1, V2, V3 and so on. How do I give the name for the edges? Now in this case, we have given the name for the edges. V1 is connected to V2, I'm giving it as E1. V2 to V3 as E2 in this particular graph. But usually how do we give the names? It says when you have to walk, assuming V1, V2, V3, V4 are your cities and V1 connected to V2 is your road. So you have to walk from V1 to V4. How are you going to walk? You can go from V1, E1, V2. Now, why am I saying V1 even V2? Because there might be an alternating path also. Instead of taking E1, sorry, instead of taking E1, I could have taken this path which is E9. So I could have taken V1, E9, V7, E8, V2, E2, V3, E3, V4. Either I could have taken a direct path or I have taken this particular path from V1 to V7, V7 to V2, and then to V2, V3 to V4. But from V2 to V3 to V4, why should I take this? I can also take V2 to V6, V6 to V4. I could have taken that path. So in this case, it says what is a walk? It is a finite alternating sequence. Your walk has to stop somewhere, hence it has to be finite. Finite alternating sequences of vertices and edges, that is V0, E1, V1, E2, V2, E3, V3, and so on, EK, VK, where I is between 1 to K and the edge is EI. EI connects VI minus 1 to V1, VI minus 1 to VI. That means E1 is connecting V0 to V1, E2 is connecting V1 to V2 as per the definition. In this particular graph, I have so many walks. So many walks in the sense that I can also go from V1, E10, V7, E9, V1, E1, V2, E4, V5, E6, V5, E7, V5, back to V6, and follow this path to V4. Please note, walk says you can visit the vertex and you can visit the edges as many number of times as you want. There is no restriction in the walk. Note this. A walk from a vertex V0 to Vn in a graph G may be denoted as V0 Vn walk. V0 and Vn are termed as end or terminal vertices, while all the other vertices are termed as internal vertices of the walk V0 to Vn. It is as good as somebody is asking you to travel from Ulhasnagar to Dadar. Now, how do you go from Ulhasnagar to Dadar? It is up to you. If you're traveling by rail, definitely there are some stations in between. You'll have to travel those stations. But if you're traveling by road, then in that case, you have to decide which road are you taking. There is not single road which is going from Ulhasnagar to Dadar. There are multiple roads. So you'll have to decide which road you're taking. But my terminal vertices are Ulhasnagar and Dadar. Intermediate wherever you're stopping, those will become your internal vertices. The second thing is, in a walk, edges and vertices may appear more than once. So you can always visit that particular place again and still continue your walk. Third, it says, as walk is called, a walk is called open when the terminal vertices are distinct, while a walk is called closed when the terminal vertices are same. That means if in the previous graph, if I start from V1, I go from V1, E1, V2, E8, V7, E9, V1. Now check, this is a complete path. It is as good as you start from your home, you visit one place, you visit second place, and after that you go back home. That becomes your closed walk. But if you are moving from one place to the other, from V1 to V7, you want to move through V2. So V1, E1, V2, E8, V7. V1 and V7 are not same, hence we call it as open path or open walk. So walk is open when V0 and Vn are distinct. A walk is called closed when V0 and Vn are same. Please take the screenshot for this note because I'll be requiring it very often. Is it done? Okay. Then we're proceeding with the trail. Now, please note in the walk, what was there were no restriction on the times you're visiting vertices and edges. That means vertices and edges could repeat. But here it says a walk is called a trail if all its edges are distinct. That means when you're going to go through the walk, you can go through the edges only once. You cannot traverse it again and again. A trail is open or closed depending on whether the terminal vertices are distinct or same. Trail is you're going through that path only once. You cannot go through that path again or through that particular edge again. What is a path? Path is an open trail. And if your trail is closed, we call it as a circuit. Please know the difference between walk, trail, path, and circuit. What is a walk? As many number of times you want to visit the vertex, visit. As many number of times you want to visit the edges, visit. But if you have a walk in which all the edges are distinct, that means you have gone through those edges only once, then we call it as a trail. If trail is open, that means first vertex and the last vertex is not same, we call it as a path. But if first vertex and the last vertex is same in the trail, we call it as a circuit. We proceed further and we call it as a cycle. What is that? Now we are putting the restrictions on vertices. It is a circuit that does not have any other repeated vertex except the terminal vertices. So how did we start with? From walk we have gone to trail. In the trail, all the edges are distinct. Then we said if trail is open, we call it as a path. If trail is closed, we call it as a circuit. We went further. From the circuit, all the edges are distinct. Now we put up restrictions on vertices. If all the vertices are also distinct, except the first and the last vertex, then we say that these are, this is called as cycle. Please take the screenshot. The next definition we are proceeding is connected graph. A graph is called connected if a path in it exists from a vertex to any other vertex. That simply says that you will say there is a connectivity between the cities if you can go from one city to any other city. Hence, we will call it as connected. But if you want to go to island, maybe you want to go to Alibag or some particular place, there is no connectivity through road. We will call it as disconnected. So this is if such a path does not exist, the graph is said to be disconnected. So if you can go from one vertex to the other vertex, and if that path exists, we will call it as a connected graph. Please note path. Path is an open trail. In the trail, we visit the edges only once. If such a path does not exist, the graph is said to be disconnected. If I have a disconnected graph, I will have various connected pieces of the disconnected graph. Those pieces are called as components. So if I have a disconnected graph, in that disconnected graph, its subgraph will be connected. So if subgraphs are connected, maybe I will have two pieces, three pieces, four pieces. All those pieces will be called as components. Take the screenshot for this. We're proceeding further with Eulerian path. Now, what is an Eulerian path? An Eulerian path in a connected graph G equal to VE is a path that traverses each edge in G only once. Please note now what is the difference between your path and Eulerian path. In the path, it says you are visiting from one vertex to the other vertex and the edges should be distinct. But what is Eulerian path? Eulerian path says you are starting from first vertex till the end vertex and you have to traverse all the edges of the graph only once. I'll repeat what I said. In a path, you're supposed to go from one part to the other part or from one vertex to the other vertex, say V0 to V5. If you're going from V0 to V5, whatever edges you're taking, you should be taking it only once. But in the Eulerian path says when you're going from V0 to V5, you have to go all through the path only once. So if there are 5 or 10 edges in a graph, you should go through all the edges and reach there. So it says if you have to go from Ulasnagar 1 to Ulasnagar 5, do not go directly. You will have to go through all the paths of Ulasnagar to reach to Ulhasnagar 5. So from 1 to 5, don't go directly. You have to go through all the graphs, all the paths which are available. That is the main difference between your path and Eulerian path. Eulerian path says you have to traverse each edge. हर एक रास्ते से जाना है. Is this point clear? Then we have an Eulerian circuit. Circuit says it is a closed path. So when your Eulerian path is a circuit, we call it as Eulerian circuit. Now check in this case. We want to know, are there any Eulerian paths in this? I want to go from A to D, or maybe I want to go from A to B. You'll say A to B, I directly have A to B. So if I have A to B, I can go directly. No. If you want an Eulerian path, you have to visit all these things. So from A to B, B to C, C to D, D to E, and E to B. That becomes my Eulerian path. I have to visit all the edges once. There is one more path in this. B to C, C to D, D to E, E to B, and B to A. So this is, please note this, A, B, C, D, E, B, or B, C, D, E, B, A. These are both Eulerian paths. Is it fine? We will take this step further, Eulerian paths, in the next session. Using Eulerian path, we will be solving our first puzzle of Königsberg's bridge problem. I will stop here.
Hello everyone. Am I audible to all of you? Okay. So in last session, we have completed our unit 1. Do you have any doubt in that? We have seen so many constructions of DFA, NFA, melee and body machine. And in the second part, we have seen what is a formal language and what are the terminologies of basic formal language, and which language is for which machine, which grammar is using which grammar we can construct a language and for which machine. Any doubt till you? Am I audible? Okay. So shall we proceed with the unit 2 or you have any confusions or doubts in unit 1? Okay. Let's start with your unit 2. In unit 2, we'll be looking at what are the regular sets and regular grammar. The definition of regular grammar we have already seen. Now we'll be looking at what are exactly regular sets and how regular grammar and regular sets are connected. And there are a few proofs on the rules of regular grammar and regular sets. So I'll be starting with regular sets. Please check. This is your syllabus part. So we'll be covering regular expressions. What are the regular expressions? We'll be seeing finite automata and the regular expressions associated to that finite automata. Then we have pumping lemma and its applications and the properties. So pumping lemma is a theorem. So we'll be looking at that. And finally, we'll see what is a regular set and regular grammar. So let's look at the definition of regular expression. What do you mean by an expression? Yes, I'm expecting the answers. What do you mean by an expression? Can we say a plus b plus c is an expression? Can you hear me? Okay. My question was, can we say A plus B plus C plus D is an expression? So now, in regular expression, what we are trying to do, we are trying to represent our grammar in terms of these mathematical or algebraic expressions. So we'll be using these symbols, multiplication and plus, based on the rules. So first look at what are the rules we have. Check it. Regular expression, as I told you, regular expressions are used for representing certain sets of strings. Strings कहाँ पे रहेंगे? आपकी grammar में रहेंगे. So regular expressions are used to representing certain sets of string in algebraic fashion. We'll be using these mathematical functions to represent our symbolic or strings. Please check regular expressions over sigma. Sigma kya hai? That is your alphabet set, right? That will be having symbols for creating your strings. Regular expressions over sigma are precisely those obtained recursively by the application of rules once or several times. So we should be aware with the rules. Which rule is going to get me which particular mathematical symbol in my expression. Okay. I repeat, regular expression is used for representing certain sets of strings in algebraic fashion. We'll be converting our regular language, or you can say a strings which are in my grammar, into an algebraic form using these regular expressions. And regular expression over sigma set of alphabets are precisely those obtained recursively by application of rules one time or several times. Recursively is repeatedly. Okay. So we'll see what are the rules we have and how to apply these rules onto your strings so that we'll get the regular expression. Is the definition of expression clear? Is the definition of regular expression clear to you people? Let's look at the rules. So rule 1 says epsilon, which represents the empty string, right, is a regular expression indicating the language containing an empty string. So epsilon alone is a regular expression. So each and every symbol alone is also a regular expression along with epsilon. Epsilon is nothing but a null character in the set of strings, and that is alone a regular expression, indicates the language containing an empty string. My second rule says, so if your language has only epsilon, this will be a regular set. Is it okay? Language only containing epsilon, my regular set will have only epsilon. Is it okay? Please check. Second rule. Now we have 5. That stands for null, is a regular expression denoting the empty language. Please check the difference. We have an empty string, we represent with that epsilon, and the language is empty, we represent it with 5. So can you tell me what will be in my language set? Pi is nothing but a null, right? So that represents empty language or a null language. So do we have any character in my language? No, right? So my language will be only empty curly braces. Please check we don't have an empty string. Is it okay? Empty string and a null language. Epsilon represents empty string. If you are creating a language using epsilon, that will have a single string present in your language set, that is epsilon. And if you are saying it is a null language, so we'll be expressing it with L of null, and in your set we have nothing, not even in epsilon. Next is a regular expression where X is any symbol. So X can be any singleton symbol, A, B, C, D, capital, small, your characters 1, 2, 3, or any symbols which can be the part of your symbol set that are regular. So we have seen epsilon, null string is regular. We have seen if my set does not contain anything, that is also regular. And we have any singleton symbol, that is also regular. Is it okay? Shall we proceed? Okay, so singletons are done. Now we have seen we have combinations of our symbols in my language. Like we have A, B, we have triple A, we have 4 times B, right? So what about those? What about those strings? So those strings are formed using some rule on your singleton symbols, right? We concatenate, we take the union of that, we'll take the star, clean star, or positive closure of that, and then only we got that strings. So what about those strings? Are they regular or not? We'll see. So if R1 and R2 are regular expressions, if R1 is a set, R2 is a set, and these are nothing but the set of regular expressions, then the union of R1 plus R2 is also a regular expression. Check it. The next rule says R1 and R2 are regular expression, then concatenation is also a regular expression. Union, the definition is same as that of your set. The language can contain the element from set 1, it can contain the element from set 2, it can contain the element of both the set. Concatenation, R1 and R2. How do we represent concatenation? We have seen how to concatenate two strings. Can anybody tell me? What do you mean by concatenation? Concatenating a strings. Yes, what do you mean by concatenating a string? You remember we have seen the definition of concatenation of two symbols. Now we have seen a singleton symbol is a regular expression. Then if you concatenate two singleton sets, singleton symbols, say A and B, your string will become AB, right? So can we say AB is also regular expression? Rule 3 says X is a regular expression where X can be any symbol. Now suppose my symbol is A in my R1. R2 contains a symbol B. So if we concatenate R1 and R2, what will be the output? Will it be AB? So can we say AB is also a regular expression? Okay, so we got the rules for the string whose length is more than one, right? Now you have created a string which is more than one, which is two. Now you have just proved that AB is a regular expression. Now let's connect it again with R1, AB and R1. Again, it will create ABA. That is also a regular expression now using the rule number 5, right? So this way we can conclude all these strings which are created with the set of symbols are regular expressions. In that we have seen empty string epsilon is a regular expression. If your language contains nothing, it is a null set. It is an empty language, that is also a regular expression. Is it okay? Is it okay, guys? I'm not getting any response. Okay, let's proceed. So I'll be using these rules frequently, right? So check here. Empty string, epsilon is a regular expression. Language, if language is empty, L of null, it's contain nothing. That is also regular expression. Any singleton symbol is a regular expression. If we perform any operation such as union or concatenation on that symbol, that is also a regular expression. And finally we have closure. If your R is a regular expression, its closure will also be a regular expression. That is a key closure, star closure. Can you tell me what is a star closure? We have seen these terms, positive closure and star closure. What will be the star closure? If R is a set of few symbols, what will be the R closure? Yes, can we say it is nothing but the all strings, all possible strings containing the symbols from R? I got one answer from Harsh. Harsh is saying set of all strings. Can we say all possible strings which can be made from the symbols of R? Will it contain epsilon? Do we have epsilon in star closure? Yes, we have epsilon in star closure. Do we have epsilon in positive closure? No. So positive closure is nothing but set of all possible strings excluding your empty string. But including will be the star closure. Okay, let's look at few examples. Please check. Example number 1. Now I'm using these rules. Example number 1 says three symbols 0, 1, 2. Can you see the three symbols? We have three symbols in my first set 0, 1, 2. I'll be converting that language into a regular expression. I have replaced comma with or, and or is nothing but plus. I'm using the union operation here, right? We have seen singleton symbol is a regular expression. And if you take the union of these symbols, that will also be a regular expression. So I'll be using the union operation here, and my expression is my first symbol 0 plus 1 plus 2. So this is how you have to convert your language into the regular expression. Easy. I'm using my union here. Please check. We have three symbols in my language: 0, 1, 2. Now we have to convert this language into a regular expression. So I'll be using union here. My first symbol is 0, my second symbol is 1, and my third symbol is 2. Now my language says it can contain all these strings of 0, all these strings of 1, all these strings of 2, or combination of any of them, right? And that is nothing but the definition of union. So we represent union with the plus symbol. Just now we have seen, right? Check here. Please check union with the plus symbol and concatenation with the dot symbol, right? So if I take the union of three symbols, my expression will become 0 plus 1 plus 2. Is it clear? Check the second example. In second example, we have first character is nothing but null, or you can say empty string, right? And my second string is AB. First of all, tell me, is this character? That is nothing but an epsilon. Is it regular expression? Is my first symbol is a regular expression? Is epsilon a regular expression? Priyanka is saying no. But the answer is yes. We have seen the first rule, epsilon is a regular expression. Please check. Okay. So epsilon is a regular expression and we have a symbol of length 2. That is AB. That is nothing but the concatenation of symbol A and symbol B. Right? So can we say AB is a regular expression? So if I take the union of these two, since this is the epsilon, this will go away. We left with AB. So my regular expression is AB for a language containing epsilon and AB. Is it okay? Okay. Let's look at the third example. Our language has A triple B and a singleton set A, then we have B, then we have double B A. Can you tell me the regular expression for this? What will be the regular expression of this particular set of language with the four symbols A triple B, A, comma B, comma double B, A? Yes, I'm waiting for your answers. What will be the regular expression RE for this language containing A triple B, A, comma B, comma double B, A? I got one answer from Harsh. What about others? To convert this expression in convert this language into the regular expression, you can use either concatenation or union. I'll be using union here. It's up to you. You can use concatenation also. Since we have four symbols, A, triple B, A, B, and double B, A. So I'll be taking anything out of these symbols in my regular expression. So that will become the union of this. My expression is A triple B plus A plus B plus BBA. Here plus symbol is nothing but it represents OR, right? So my language can contain A triple B, it can contain A, it can contain B, or it can contain BBA, or combination of them too. Are you getting how to read a regular expression? Plus is a union. Union ka same definition which we have used in our set theory. It can contain the element of set 1, set 2, or both of them. Okay. Let's look at the fourth example. Tell me the regular expression for this. It is an infinite language where my symbols are epsilon, null, comma, 0, double zero, triple zero, 4 times 0, and so on. Can you give me the regular expression for this? Yes, can you give me the regular expression for this in infinite language? Did you notice we have all possible strings of 0 of length 1, 2, 3, or so on? I got one answer from Sanjana. I repeat, we have all possible strings which contains 0 of length 1, 2, 3, and so on. So there are two closures which will give you the all possible strings of any particular string. We have seen two closures, positive closure and star closure, right? Which one is this? The plus closure or star closure? It is a star closure. So instead of writing R is equals to 0 plus double 0 plus triple 0 plus so on, can we write it as this is star closure? And we have already written in the rule number 5 that star closure, in the rule number 6 that star closure is a regular expression, right? So regular expression for this example is a closure of 0 and that will become 0 star. Okay. Is the concept of converting language into the regular expression clear to you people? Okay, let's proceed. What about this example? What is the regular expression for this particular set of language? I got one answer from Harsh. Anyone else? Can we say this set contains all the possible strings made up of one? Yes, do we have all the possible strings of length 1, 2, 3, and so on of symbol 1? Do we have epsilon here? We don't have epsilon here. So which closure? Plus or star? Plus closure. But we have no rule saying that your positive closure is also a regular expression. We have rule for the star closure. So how do you justify your answer? We have seen star closure is a regular expression. We have seen epsilon is a regular expression, right? Since your regular expression is nothing but the algebraic expression or a mathematical expression, can we say star minus epsilon? My first set is nothing but a star closure minus epsilon, that is also a regular expression. So plus can be a regular expression, right? Second, closure of one excluding null, that is epsilon. So that is my 1 plus positive closure of 1. Justify your answer, you can write down star closure of 1 is a regular expression and epsilon is also a regular expression, right? So the positive closure of 1 also will be the regular expression. Okay. Let's look at the another example. What about this? Try to convert this language into a regular expression. So I'm waiting for responses. Yes, just forget about the fourth string, that is 0, 1. We have only consider we have three strings, epsilon 0 and 1. What will be the regular expression for that? Will it be epsilon plus 0 plus 1, right? I repeat, just consider first three strings in my language, that is epsilon, 0 and 1. What will be the regular expression for these three symbols? Will it be epsilon plus 0 plus 1? Now check our fourth string, 0 and 1. Is it a combination of my second and third string in my symbol? My fourth string is 0, 1. Is it a combination of second and third string, which is 0 and 1, right? Nothing but the concatenation of these two symbols. 0, 1 is the concatenation of 0 and 1, right? And 0 can be considered as a concatenation of epsilon and 0. Are you getting? Can we say 0 is nothing but the concatenation of epsilon and 0? We have seen if you concatenate epsilon with any string, that will become a string only. And 1 can be written as epsilon and 0. So how can you write the regular expression for this language? Considering all these relations in between the symbols. If your language will contain only two symbols, that is epsilon and 0, how would you write? Yes, think, if we have only two symbols in my language, epsilon and 0, what will be the regular expression for that? Which means your language can contain either epsilon or 0 or combination of both. That is also 0, right? So can we write for epsilon and 0, epsilon plus 0? Since we are taking union of epsilon and 0, can we write epsilon plus 0? Now let's consider two more strings, that is epsilon and 1. How can you write epsilon and 1? Yes, how can you write epsilon and 1? Can we write epsilon plus 1? Sanjana is saying epsilon plus 1. So we got two regular expressions here, epsilon plus 0 for the symbols epsilon and 0, and epsilon plus 1 for the symbols epsilon and 1. What about 0 and 1? What about the last symbol 0, 1? Since that is nothing but the concatenation of 0 and 1. So can we merge the first two expression which we have generated just now? Epsilon plus 0 and epsilon plus 1. If I concatenate these two expressions, can we get 0, 1? Please check. This is my regular expression. You have converted epsilon and 0 into epsilon plus 0. epsilon and 1 into 1 plus epsilon, right? Now, fourth symbol है आपका 01. How can we obtain that symbol using this expression? Since we are using concatenation, तो इसमें से कौन से strings बनेंगे? We'll take the first one, 0, give it to this and give it to this. So 01 will be there, right? I have taken 0 from this set, 0 and 1. So my string is 0, 1. 0 and epsilon, that is nothing but 0. Now take epsilon, epsilon and 1. This will be 1. Epsilon and epsilon, this will be epsilon. Are you getting how to convert a language into a regular expression? So this regular expression is going to generate only 4 terms for you. That are nothing but the terms which are mentioned in the language set. I repeat, we'll take the first element of this set, 0 plus epsilon, and multiply it with both the elements of set 2. Multiply matlab concatenate करें, right? So 0, 1 will become 0, 1. 0 epsilon will become 0. Now let's take the second symbol of this set, that is epsilon. Epsilon 1 will become epsilon 1 and epsilon will become epsilon. So you have to think little bit looking at the language set. Can we combine any of them? How my elements and symbols are connected to each other? Is it okay? Okay. Let's proceed with the last example. Check. Can you give me the expression for this particular set? That is an infinite set. Wherever we have infinite set, we'll be using some closure because we are not going to write each and every string in my expression, right? So we'll be using some closure. Tell me what is this? Please look at these strings carefully and think. Let's consider the first three strings of this language, that is epsilon, A and B. What is this? If your language has only three strings, that is epsilon, A and B, how do you represent it in the regular expression? Which means my language can contain epsilon, my language can contain A, or my language can contain B. Just forget about the epsilon also. Just take only AB. So how will you represent a language? How will you represent this language using the regular expression? Sanjana is saying A plus B. What about others? If my language has only two symbols, A and B, which means my expression can contain A or expression can contain B. So we'll be using the union operator here. So my RE will become A plus B, right? Now look at the other strings. The fourth one is AA. Is it made up of my first string which we have just constructed in my union? Yes. Next we have AB. Now you just have said A plus B will be your expression. A plus B will derive the strings A, B, AB, right? If we take a star of that, can I get this language? If I take the star of union A and B, can we have this language? Please check. Your union will have A plus B, which means we can have a string A, we can have a string B, or we can have combination of them, that is AB or BA. Now check. If we take a star of the union, can we have this language now? Double A is nothing but the string which is made up of A. AB is already in your union. BB is a string which is made up of B. BA is already in your union. Then we have triple A that you can get from the star A, right? And since we are taking star closure, your epsilon will also be included. Is it? So what will be the regular expression for this language? When we say A plus B star, so we'll be taking star closure of union A and B. Check here. Is it clear? अगर स्टार हटा देंगे तो A plus B will give you a string A, string B, string AB and string BA. Now we have 4 strings in my set. If I take a star of each and every one, which means A star, B star, AB star, BA star. So we'll get this set along with epsilon since we are taking a star closure. अगर epsilon नहीं होता तो हम लोग यूनियन का पॉजिटिव क्लोजर. Is it okay? So did you notice we have used each and every operator which we have read in the rules? I have used all of them in my examples. We have used concatenation, we have used union, and we have used star also. And singleton to बहुत easy था. You just take a symbol and put it in a union, right? Shall we proceed? Now, such conversion of expression you can expect for 1 mark in the first question, where we have one mark wala questions. Shall we proceed? Please check. We have seen regular expressions now, how to represent your language using a regular expressions. For that, we have seen few rules and we have converted our language into a regular expressions. Now check, we have regular sets. This definition says any set that represents the value of regular expression is called a regular set. I repeat, any set that represents the value of regular expression. I'm not saying regular expression, value of regular expression is called as a regular set. Is it okay? Now we have few properties for regular set. Now this particular thing is very important, bit theoretical, but these properties are very important. We are going to prove this each and every property. So you can expect these properties in your examination. Please check. The union of two regular set is a regular. We are talking about set, not the expression. Because expression mein we already seen there is a rule that if you take a union of two symbol, that is a regular expression, right? We have read this rule in the rule wala slide. Now we are talking about regular sets. The union of two regular set is a regular. We have to prove this. Then we have another property. The intersection of two regular set is a regular. Set regular kabhi rahega when it contains all the values of regular expression, right? So we are going to prove that all the values in my set are nothing but the regular expression. And we have seen what is our regular expressions. Regular expression where we have absent, we have null, we have singleton symbols, we have concatenation of the symbols, we have union of the symbols, and we have start closure of the symbols. Right? So you have to keep those rules in mind. Based on that rules, we are going to prove these properties. Okay, so don't get confused between the set and the expression. Set क्या है? That will be containing all the values of your regular expression. Regular expression क्या है? आपके language को algebraic form में कैसे represent कर सकते हैं? That is nothing but a regular expression. Is it okay? Shall we proceed? Is there any confusion between regular expression and regular set? Should I repeat the definition of both? Okay. Harsh is saying it's clear. I'm assuming it's clear to all of you. So we have properties of regular expression. My first property says, sorry, regular sets. My first property says union of two sets will be regular. Intersection of two sets will be regular. Then we have complement of regular set is a regular. The difference of regular set is a regular. The reversal of regular set is a regular. Now, before proving them into the regular, are you clear with the definition of union, intersection, complement, difference, and reversal? Union and intersection to सबको पता है, right? Union is nothing but if I'll take the union of set A and set B, all the elements of set A will be included, all the elements of set B will be included, right? We'll have everything in my union. Intersection में we'll be taking only the common part. Complement में we'll be taking the elements which are not included in a particular set whose complement we are taking. So if we take the complement of A, so all the elements which are in the universal set but not in A will be in the complement set. Difference में if say A minus B, if we take a difference of two sets, say A minus B, किसके elements रहेंगे और किसके नहीं रहेंगे? I'm talking about the set theory which we are using since our school days. If, so what is the difference of two sets? Difference of two sets will be all the elements which are there in my set 1 but not in my set 2. So the common elements of A and will be, B will be excluded. Rest all elements of A will be considered in my difference. Reversal may will be reversing the elements in my set. If AB is a if AB is a element of my set, reversal may it will become BA. Okay, so we are going to prove these things that are the regular expressions. Shall we proceed? Please check. The closure set, the closure of regular set is regular. The concatenation of two regular set is a regular. Closure we already know, concatenation is also known to you. So I'll start with my first property. These proofs are very, very important. You can expect these proofs in the examination for 5 months. So please be attentive. The union of two regular set is a regular. Proof for that, let's take two regular expressions. I'm taking two regular expressions, not the sets. R1 is nothing but A double A star. and R2 is double A star. So we got two regular expressions, right? What will be the values of R? Can you tell me which kind of strings will be in my set R1? Okay, at least tell me the first string in R1. Meenakshi is saying A. If you take a star closure of AA, the strings will be epsilon, double A, 4 times A, 6 times A, and so on. So there will be strings of even length, can we say? Can we say that? Double A star will contain all the possible strings of A with even length, including epsilon. So epsilon, A concatenation epsilon will become A concatenation double A will become triple A concatenation 4 times A will become 5 times A concatenation 6 times A will become 7 times A. So in R1, what kind of strings are you having? You told me one string that is A is there. What about the other strings? Tell me the second string in R1. Yes, what will be the second string in R1? Priyanka is saying AA. No, that is not a correct answer, Priyanka. Sanjana is saying triple A. That is the correct one. What will be the third symbol in R1? See, A is fixed. Now we have another set which is nothing but the closure of AA. Closure of AA may you will be having all possible strings of A of even length, right? So AA with A will become 3 A's. 4 times A will become 5 A's. So can we say R1 will have all these strings of length which are odd in the number? Priyanka, is it okay? So AA cannot be here, right? Are you able to convert a regular expression into a language? Now my language is nothing but strings of A, all possible strings of A in odd length, right? What about R2? R2 में क्या रहेगा हमारे पास? AA will be my first string. What about the second string? 4 times A, then we have 6 times A, then we have 8 times A, and so on. So can we say this language will have all the possible strings of A with even length, right? So R1 is nothing but all the possible strings of A in odd length. R2 is the all the possible strings of A in even length. If we take a union of both, what will be my final set? अगर मैं सारे A's even length वाले और सारे A's odd length वाले एक जगह पे लेके आऊं, so will it become all the possible strings of A of any length? I got one answer from Sanjay. Yes. How do we represent all possible strings of A of any length? A star. And we have already have ruled that A star is a regular expression. So hence proved. Can we write hence proved now? समझा के repeat कर. We are trying to prove union of two regular sets is a regular, right? We have taken my first regular expression as A double A star and R2 as double A star, right? We have to prove that union of R1 and R2 is a regular expression. R1 may say we have identified that R1 will have A wala string in odd length and R2 will have all possible strings of A in even length. If we take the union of both, our answer will be A star, right? All possible strings of A. And that is already a regular expression by the rule. Check here how to write. L1 is nothing but A, triple A, 5 times A, and so on. So L and L2 is epsilon, double A. Please check in L1 we can't have epsilon because double A will have epsilon, but if you take the concatenation of epsilon and A, it will become A. So we cannot have epsilon in L1, though we have a star closure of AA because A string is fixed. जो फर्स्ट वाला ए है वो फिक्स्ड है, राइट? दिस सेट विल गिव यू एप्सिलॉन डबल ए 4 टाइम्स ए 6 टाइम्स ए. तो एप्सिलॉन को आप जब ए से कॉन्कैटिनेट करोगे यू विल लेफ्ट विद ए, देन वी हैव डबल ए विद ए, दैट विल बी ट्रिपल ए, राइट? Is it okay why we don't have epsilon here? Okay. So my L2 is nothing but epsilon. Since we don't have any fixed string, we have just closure epsilon A 4 times A, 6 times A, and so on. L1 union L2. I am merging everything. So epsilon I have taken A, double A, triple A, 4 times A, 5 times A, so on. And that is nothing but A star, right? Which is a regular expression itself. Is it clear, guys? Union of two regular set is regular. Is it clear? Now the statement says union of two regular set is regular, but we have proved that two regular expression and we are taking the union of two regular expression that is regular. But what is a regular set? That is nothing but the values which are regular set, regular expression, right? So can we say union of two regular set is a regular now? Okay, let's move to the another proof, intersection. Please take down the screenshot. Huh? Intersection of two regular sets is a regular. Check it. Let's take two regular expression. My A R1 is A and A star and R2 is double A star. Tell me what my R1 language contain and what will my R1 R2 language contain. What will be these strings which are in R1 and R2? Let's start with R1. Tell me the first string of R1. That is very easy. A. What about the second string? AA. Third string, triple A. What is R1 now? Tell me. Can we write it is a star closure of A? No, we can't write that because we can't have epsilon in R1. Though we have epsilon in A star, but we merge that epsilon with A, that will become A. So that is a positive closure of A. Is it? Let's look at R2. Tell me the strings which we'll be having in R2. Double A will be the first one. 4 times A. So that is nothing but the all strings of A which will be in the even length. Is it? Yes. R2 will have all these strings, all possible strings of A in even length, right? And R1 may we have A positive means all possible strings of A excluding epsilon. Do we have epsilon in R2? Do we have epsilon in R2? Yes, but in R1 we don't have epsilon because one A is fixed. Now tell me, if you take the common of these two sets, A plus and all possible strings of A in even length, what will be the common part? Intersection is nothing but taking common elements, right? Can we say R2 is nothing but a common part? Because आपके सारे जो भी strings R2 में रहेंगे वो R1 में तो है ही है, right? Except epsilon. So R2 except epsilon will become आपका R2 है AA closure, AA star closure. Minus epsilon करोगे तो it will become AA plus. Is it? I repeat, R2 में we have epsilon, double A, 4 times A, all possible strings of A in even length. Now, if we take common of both, we'll have all the elements of R2 in R1 except epsilon because we don't have epsilon in R1. So your R2 minus epsilon, that is the common part. That will be my intersection of R1 and R2. And we have seen positive closure is also a regular expression, right? Please check how to write. L1 will have A, double A, triple A, 4 times A, and so on. Please check we don't have epsilon here because one A is fixed. L2 will be having epsilon, double A, 4 times A, 6 times A, and so on. All possible strings which are made up of A, but even in length, along with epsilon. If you take a common of these, tell me what will be the common. Tell me the first common string in L1 and L2. AA, second common string, 4 times A. If you take the next common string, that will become 6 times A, and we'll have 8 times A, right? Can we say that is a positive closure of AA? Please check. If we take the intersection of L1 and L2, we have AA and AA star. Now I have used this notation. If you want, you can write the positive closure also. Why I am using this one? Because for AA plus, we don't have any rule. We don't have any rule for the positive closure, but we have rule for star closure and a string which is made up of concatenation of two singleton symbols. So AA is a concatenation of A, and AA star is itself a regular expression. Is it clear why I am using this notation? I have fixed AA and I am taking AA star. If you expand this, this will become epsilon AA, then AA 4 times, 6 times A. Then you have to multiply AA with the AA star. So your epsilon will become AA after concatenating it with AA. Is it okay? AA plus भी लिख सकते हैं, but we don't have any rule which is there saying that positive closure of your string is regular. Rule is for star closure, right? So I'm writing the AA plus in the form of star closure and concatenation of A and A. Because concatenation is regular expression, star closure is regular expression, then that two together also a regular expression. Okay, intersection clear. Let's move to the another property, complement. Please check. I need only one set. So my R is AA star. I have to prove complement of AA star is also a regular expression. What will be the complement of AA star? So let's start with the R. What will be the strings in my R? Tell me the first string in R. Only Sanjana and Priyanka are replying. बाकी लोग क्या कर रहे हैं? सो रहे हैं. If you reply, you will remember the things. If you will not, you're just looking at the slides. You will not get anything once you open that slides after some time. Okay. So we have AA star. If we say it is a AA star, my language will become AA 4 times A, 6 times A. That is all possible strings of A of even length, right? Check here, including epsilon, because we have star and we won't have any fixed A or AA. Right? What will be the complement of this? We have A, we have triple A. Yes, Priyanka, we have 5 times A. So can we say all possible strings of A in odd length, right? Will it include epsilon? No, we will not be having epsilon in the complement. Check it. So my L complement is nothing but A, triple A, pi times A, and so on. That is odd length excluding epsilon. Now check how I have written my odd length wala set so that I can show that that is a regular expression. I have fixed my A and A star. A star is already regular given in the question and singleton sets are regular, right? So A is a regular by the rule. That is my third rule, I guess. That is a singleton symbols are always regular. And A star is a given in the question that that is a regular, right? So can we say A concatenate A star is a regular? Just I'm manipulating, I'm representing my A complement so that I can prove that are regular. कैसे बताएंगे कि A star already given in a question that is a regular. I have concatenate the given set with A so that I'll be having all these strings of odd length excluding epsilon, right? And concatenation of singleton set and the star closure is a regular. Is it? So we have proved the complement of a regular expression is a regular. Any doubt in this representation? I hope by now it is clear, right? I'm fixing one A and taking the star closure of AA. So that will give me AA 4 times A, 6 times A, and so on. If you multiply that with A, your epsilon will become A, then 2 times A will become 3 times A, then 4 times A will become 5 times A, which means I'll be having all A's of odd length. That is nothing but my L complement, right? Shall we move to the next property? I hope by now how to write a language into a regular expression and regular expression into a language, it's clear to you people, right? I'm using all the rules. Concatenation be union be star be. Please take the next property. The difference of two regular set is a regular. Check it. My two sets are R1 is A star and R2 is double A star. What is my R1? It will have A's of even length or odd length. Or all the possible A's. Sanjana, will it be A star or A plus? Since we have one A which is fixed here, right? So A into A star will become positive closure of A because आपका epsilon A बन जाएगा. So we'll be having all the possible strings which are made up of A excluding epsilon, right? Please check what do we have in R2. Even or odd? Even, right? Now my first set is having all the possible strings which are made up of A, excluding epsilon, and second set is having all the possible strings made up of A, even in length, including epsilon. What will be the difference if I'll say R1 minus R2? तो क्या डिफरेंस रहेगा आपके पास? ऑड वाले रहेंगे सारे डिफरेंस में, इवन वाले तो कट कर देंगे ना हम लोग, राइट? R1 में सारे possible strings है which are made up of A. R2 में we have all possible strings which are made up of A but even in length. What will remain in R2? What will remain in difference R1 and R2? All the possible strings which are odd in length, right? Do we have epsilon in the difference? Please think, do we have epsilon in the difference? Difference का definition बोलता है all the elements of set 1 but not the elements which are common with set 2, right? We'll be considering all the elements of set 1, which means R1, but we'll be subtracting all the elements which are common with R1 and R2, and that are nothing but A's with even length. So we'll remain with the A's with odd length in the difference, excluding epsilon, right? Because R1 does not have epsilon. So how do we write A with odd length using the star closure? We can't write A plus. I got one answer from Priyanka. It's A and AA star. Will it give you all the possible strings of A in odd length? Right? So that is, these two are already regular. Star closure is regular, singleton is regular, concatenation of these two will also be regular. Right? So check it. L1 is having all these strings which are made up of A excluding epsilon. Then we have R2 including epsilon. We have all the possible strings of A even in length. If I set the difference of L1 and L2, I'll be getting A, triple A, 5 times A, and so on. Because all the possible strings or even in length will be subtracted, right? And we can write this particular set as A concatenate AA star. A is regular, AA star is regular, concatenation of two regular is regular, right? So the difference of two regular set is regular. Is it clear? Is it clear, guys? Oh, let's proceed. The next one was on reversal. That is the last one, right? Reversal का मतलब क्या है? If we have a string AB in my set, if you take a reverse of that set, that string will become BA. Okay, so let's see. I have taken a set with 4 elements 0, 1, 1, 0, 1, 1, 1, 0. Right? If you take a reverse of this will become, first of all, we are creating the regular expression for this. So it will become 0, 1 plus 1, 0 plus 1, 1 plus 1, 0. Normal expression, जैसे हमने first examples में देखे. Now, take the reversal of 0, 1. My string will become, what is the reversal of 0, 1? 1, 0. What is the reversal of 1, 0? 0, 1. Reversal of 1, 1. 1, 1. Same. Reversal of 1, 0. We have already discussed that will be 0, 1. Right? So this is how I write the reversals. Check, I have just changed the position of your symbols in your string. If it is 0, 1, that will be 1, 0. 1, 0 will become 0, 1. Is it okay? If you check both the sets having exactly same elements, are they? We have 1, 0 in the given set, we have 0, 1 in the given set, we have 1, 1 in the given set, and we have 0, 1 in the given set, right? So can I say reversal is also regular since the given set is regular, right? Please check. Regular expression for reversal become 0, 1 plus 1, 0 plus 1, 1 plus 1, 0. And that is regular already by the given. Are the proofs clear to you people? Shall we proceed with the last one? Okay. The last property was the closure of regular set is a regular. Now check here. My set is L, which is having A, triple A, fault 5 times A, and so on. So all the strings made up of A but odd in length and excluding epsilon, right? And we can represent it with this expression, that is A is fixed and A is star, right? And that is already regular. We have proved this so many times. So L star will be having A, double A, 3 times A, 5 times A, and so on. So all these strings of A, excluding epsilon, but odd in length. Can we write it as like A and A star? A plus को हम लोग A और A star लिख सकते हैं. We have seen this so many times, right? We'll fix one A and A star. If we concatenate these two, that will become A plus. Is it? So now can we say that positive closure is also regular using this property? यहाँ पे closure means it is talking about positive closure because star closure is already regular, that is given in the rule. So we are proving positive closure of regular set is a regular. Is it okay, guys? Okay. So we finished proving all the properties on the regular sets. Now these proofs you can expect in your exam for 5 marks. आपको दो सेट्स अपनी मर्जी से लेने हैं कोई भी and you have to prove that after taking the union of that we are getting the concatenation of something which is already regular, which is given in the rules, right? The rules of regular expression which we have discussed earlier in this session. So singleton sets are regular, absence are regular, their union is regular, concatenation is regular, and star closure is regular. Positive closure ke liye we don't have any rule and we have just proved it. So you can't use these properties while proving the properties, but you have to use the rules, okay, which are given by the. Is it okay? Shall we proceed? Okay. Now you see, okay, go ahead. Concatenation. Let's check it quickly. Then we'll proceed how to represent the expression with the automata. Thoda interest है. Please check. We have two regular expressions. 0 plus 1, that is the union of 0 and 1. It's star and concatenation with 0. And my second expression is 0, 1. It's concatenation with 0 plus 1 star, which means union of star. Okay, we have to prove that concatenation of these two expressions is a regular. Check what do we have in L1. Since we are saying L1 में हमारे पास क्या है यूनियन का स्टार है so we can have all these strings of 0 all these strings of 1 or all these strings of 0 1 or 1 0 उसको हमको concatenate करना है 0 के साथ so we can't have null right so my first string will become 0 my second string will become 0 0 if I take only 0 1 set my third string will become 3 times 0 and so on. If you consider one wala thing, one star will give you one epsilon, one, triple one. If you multiply that with zero, that will become 1 0. Right? Please check zero बाद में है, पहले one है. So that will become 1 0. Then we have double 1 0, triple 1 0, and so on. Are you getting how am I forming the expressions? Is it okay how to convert this expression into a language? Will you be able to convert this expression into a language? We have union of 0 and 1, which means all these strings of 0, all these strings of 1 and combination of them, matlab 0 1 or 1 0, right? And we have one fixed concatenation at the back that is 0. So these are the strings which we are getting from L2. R1. Tell me what will be the strings in L2. At least tell me the first string that will be there in L2 using the R2 expression. R2 is 0 1 is fixed and उसका concatenation लेना है आपको union of 0 1 star, right? तो 0 1 is fixed. अगर आप star वाला लोगे भी element, first आपका आएगा epsilon. Epsilon into 0 1 will become 0 1, right? Now let's take the star of 0. That will give you all the strings of 0, right? 0, double 0, triple 0, and so on. If you concatenate it with 0, 1, it will give you 0, 1, 0. Is it? Then we have 0, 1, double 0. Right? Then let's take the 1. 1 star will give you 1, double 1, triple 1, epsilon bhi dega. Right? But since 0, 1 is, have already written in my set, that is fixed. So epsilon to nahi aega picture mein. So 1 concatenating with 0, 1 will give you 0 double 1. Then we have 0 triple 1 and so on. Right? So can you give me the language R2? What do we have in R2? I got one answer from Sanjana. Please check. We have 0 1 that is fixed. Then we have 0 1 0. Then we have 0 1 1 and so on. Right? Now please check. In R1, 0. Last wala 0 is fixed, which means you will get all these strings ending with 0. Right? क्योंकि आपका स्टार आपको कुछ भी देगा, यू आर गोइंग टू कॉन्कैटिनेट विथ जीरो, तो आपके लास्ट वाले स्ट्रिंग्स में जीरो ही रहेगा. इज इट? So L1 is giving you all the strings ending with 0, whereas L2 is giving all the strings starting with 0, 1. Is it? What will be in the concatenation? Concatenation में क्या रहेगा? If I give you two conditions, first condition is strings ending with 0 and we have strings starting with 0, 1. तो आपका concatenation में we are going to use both the conditions ना. Priyanka is saying ending and starting with 0. What about others? Please think. You have to concatenate L1 with L2. तो आपके L1 के सारे स्ट्रिंग्स में जीरो रहेगा एंडिंग में, L2 के सारे स्ट्रिंग्स में जीरो रहेगा स्टार्टिंग में, एंड यू आर गोइंग टू कॉन्कैटिनेट. तो L1 में जीरो के आगे कुछ भी हो सकता है, L2 में 1 0 के पीछे कुछ भी हो सकता है, राइट? तो स्टार्टिंग और एंडिंग तो नहीं है. क्या है? In between we will be having a substring that is 0 1 0, since we are concatenating it. Is it? We are not taking union of this, intersection of that. No, we are concatenating. So take the first string from L1 and concatenate it with the first string of L2. So after concatenating 0 with 0 1, the string is 0 0 1. Is it? Try to concatenate second string with second string. 0 0. If you concatenate it with 0 1 0, it will become 0 0 0 1 0. So can we say that we'll be having substring 0 0 1 in all these strings? Please check. So L1, after concatenating with L2, I'm concatenating each and every string with each and every string of L2. I'm taking one string of L1, I'm concatenating it with all the strings of L2. Then I'm taking the second string and concatenating with all the strings of L2. After identifying the pattern, you will recognize that all these strings are having substring 0 0 1 in it. Is it? Because we are concatenating two regular expression ending with 0 and starting with 0 1. तो ये substring रहेगा ना, end का उसका 0 और start का 0 1 will be there in all strings. Yes? Is the point clear to you people? So my R, after concatenating it, that will be 0 plus 1 star, which I'm taking from R1, and last wala part I'm taking from R2, or in between जो आपका fixed string है, that is 0 0 1. I'm keeping it in the middle because I want this substring in each and every string which are formed after concatenating L1 and L2. Is it? Can we say this is a regular expression? Star closure of union is regular expression. We have proved that star closure of union is regular expression. So आपका आगे और पीछे का part is regular expression. 0 0 1 is nothing but the concatenation of 0 and 1. Three singleton symbols that are regular expression, and their concatenation is also regular expression. So can we say this whole expression is a regular? So hence we proved our concatenation is also a regular. Attendance is not done with. Is attendance done? Okay. So we have completed our properties here. I'll be starting the next topic in next session. Please mention the PRNs.